How are new radars detecting air for stealth planes? Imagine trying to spot a bird in a dense forest at dawn. The bird is small, moves quickly, and blends seamlessly with its surroundings. Now, consider how military radar systems attempt to detect aircraft designed to avoid radar signals. Stealth technology has revolutionized aerial combat by reducing an aircraft's visibility to traditional radar systems. But recent advancements in radar technology are beginning to challenge these stealth features. Traditional radar systems relying on radio waves bouncing off objects to determine their location and speed. Stealth aircraft are constructed with special shapes and materials that absorb or deflect radio waves, making them less visible to these radars. The aircraft's angular surfaces scatter radar signals away from the source, and radar-absorbing coatings diminish the reflected signals. These design features significantly decrease the radar cross-section, which is a measure of an object's detectability. However, new radar systems are employing multiple approaches to counteract stealth technology. One such method involves using low-frequency radio waves. These waves have longer wavelengths that can penetrate the radar-absorbing coatings and detect objects that would otherwise be invisible to higher-frequency radars. Although low-frequency radars have less resolution and may produce more false alarms, they can identify the presence of stealth aircraft at greater distances. Another approach involves utilizing advanced signal processing techniques. These systems analyze the faint or distorted signals reflected from stealth aircraft, extracting useful information through sophisticated algorithms. By comparing the signals received from different angles and over time, these radars can identify patterns consistent with stealth aircraft, even if the signals are weak or partially absorbed. In addition, some radar systems incorporate multiple input, multiple output technology, which uses numerous antennas to send and receive signals simultaneously. This setup improves the ability to detect and track objects with low radar cross-sections by analyzing the subtle variations in the signals. Furthermore, scientists are exploring the use of passive radar systems that do not emit signals but instead analyze reflections from existing radio or television signals. These systems can detect aircraft by observing how they reflected signals from sources like commercial radio stations, providing an additional layer of detection that does not rely on traditional radar emissions. In summary, the combination of low-frequency radar waves, advanced signal processing, multiple antenna systems, and passive detection methods are enabling new radars to identify stealth aircraft more effectively. These innovations are continuously evolving, making the skies a more challenging environment for aircraft designed to evade detection.